That's crazy.
All right, so we've got, we're going to talk about the bearing of a line a little bit because this book does things just a little bit different than we do in physics, and so we have a couple of different things to look at, how they describe different angles out in the real world, but the bearing of a line,
What's this lesson called?
well, it's more applications of right triangles. And bearing of a line. So our definition of a bearing, it is the acute angle, so it means, of course, 90, less than 90, acute angle formed by the north-south line and the line L. So what they do in this textbook, they restrict all the angles to be measured either from the north-south line. So every angle on based on your compass comes from either north or south, and then it rotates towards the east or west. So the acute angle formed by the north-south line and the line L. Let me go through some examples, so I think that'll make the most sense. So if I want to draw the angle, draw. Right, the first one is north 40 degrees east. So how this book is going to do this in this system is the angle always starts from the north or south. So this one starts from the north and rotates to the east 40 degrees. Right? So here's, I guess we should review, if you're not familiar, north, south, east, west. Should have that memorized. However it works, memorize that. But we are from the north, right, measured to the east 40 degrees, so this would be the angle. So this is 40 degrees. And so it basically, right, this side here becomes the initial side of the angle. This is your terminal side. And of course, these application questions, all these will be using right triangles. Yes, so all these will. Now, when we do this in physics, in fact, we don't restrict it to north or south. We can start in the east or west. But this class, is all these will be north or south. Look at another one. If I was going to do south, 70 degrees west. So in this case, right, it's going to be that I'm going from the south is my initial side. I'm rotating to the west, right? So south, so this will be the angle, and this angle here is the 70 degrees. So pretty simple, pretty straightforward. Let's go through an example question that deals with this. So my example.
Did you have one where it goes more than 90 degrees, so it goes up into the next?
Right, and the answer is no, because by definition these will always be an acute angle. So if I would want to go more up to this quadrant here, this area, I just measure it from the north. Okay, so good question. Always will be from the north or south. So on this one we have a boat.
Can I draw a boat?
You bet. A boat travels on a course of bearing. So a lot of this is used for navigation. So a lot of examples will be navigation. North 52 degrees 40 minutes east. Right, and of course with navigation the minutes are pretty important because just a little bit off, right, if you go hundreds or thousands of miles it changes significantly where you're going to end up at. And so that's partly in navigational why we have to throw in the minutes. For a distance of 238 miles. How many miles north? And how many miles east has the boat traveled? Now, if you're in physics, often we would say on a question like this, we're finding the components of the vector. But this case, we're just looking at the right triangle part of this. Of course, the first thing you want to do is draw the angle and draw the triangle, because all these applications will make the right triangle. So, north and east, right? And from the north, it's 52 degrees, 40 minutes east. So we'll say at this angle here is 52 degrees, 40 minutes. And then it's traveled 238 miles. And of course, the question is looking for how far north did I go, right? How far north did I go? And how far to the east did I go? North and east. Okay, so I need to find, here's my right triangle, right? And I need to find this side and this side. So how should I find, let's do the north side first. How can I find the north side? Which trig function is that? Cosine. So we know that the cosine of 52 degrees 40 minutes is the adjacent over the hypotenuse. Or if I solve for n, right, I multiply both sides by the 238. So n is 238 cosine of 52 degrees 40 minutes. Now let me show you again. Some of you on the last quiz were changing the minutes before you did the trig function. Remember, you don't have to do that. You can type it all in one step. Just divide the minutes by 60 all in one step inside the trig function, and you're going to get the same answer. So on my calculator, of course, on my degree mode, always check that. But I'm going to take 238 cosine of 52 plus 40 divided by 60. Let's do it all in one step like that. And the answer is, what should I round this to? Yeah, round it since the length was in 3 significant digits. Keep that 3, 144 miles. How do I find the east?
144 squared plus e squared equals 200 squared.
Yeah, I've got a lot of options now. I could use the sine function. Or I could use the Pythagorean theorem. So Bryce is saying use Pythagorean theorem. East has to be the square root of 238 squared minus 144 squared. Remember, we'd be better off using an unrounded answer on that, but this should be, I think, what should work for 3 digits. and 189. And that's right. Okay, the assignment today. Just a short assignment again. Same type of thing. Just some application questions. So on page 89, 15, 18, 19, 23, 27, 29, and 31.